Hello, chemistry students. This is Mr. Laudermouth. Good to see you again. I'm back with the second of 3 labs that are part of Unit 2 to help us better understand learning target number 4. In this lab, we want to answer the question, what happens to the pressure of a gas when its number of particles doubles, triples, and is cut in half? In the first lab, if you recall, we changed the volume of the gas. This time we want to change its number of particles and see what effect that has on the gas pressure. So once again, we're going to graphically and mathematically model the relationship between a gas's number of particles and its pressure. We're going to GAM-TRIB again, this time using particle number rather than volume. So once again, I'm going to need a LabQuest. And just like last time, I go ahead and hook that up to my computer so you can see the readout from that. Once again, we're going to need the gas pressure sensor. You saw I had that hooked up. And we're going to need a syringe. But this time, I had to modify my syringe a little bit. It says use tape to mark a number of particles scale that we'll call the puffs scale. So I went ahead and I did that on my syringe. You can see here that I just put a piece of tape on there, and I evenly spaced, as well as I could, markings that we're just going to call puffs. Each puff is just an amount of air. And if I have 2 puffs, well, that's twice as many air particles as there are in 1 puff. If I have 3 puffs, that's 3 times as many air particles as there are in 1 puff. So no, it's not a real unit. Eventually, we will teach you about the actual unit you use for counting particles, but we don't need to worry about that here. It's actually going to make our work easier if we just say number of particles is going to be measured in this unit we'll call puffs. Okay. So we're going to record pressure and the puffs, the number of particles, at 8 data points this time. And it says, make sure the volume of the syringe is at 10 milliliters before recording the pressure. Well, wait a second. I thought we're changing the number of puffs. We're changing the number of particles, right? We are. But we need to take a minute and think about the things we don't want to change in this lab. Just like last time, I want to make sure that temperature is held constant. That won't be a big deal. It's just room temperature in the lab right now, and I don't expect it's going to change much over the couple minutes it takes me to get my data, so I'm not worried about temperature. But the other thing I do have to worry about, if I'm changing number of particles and I'm changing pressure, then I better make sure my volume stays the same. I need to keep volume constant. That's why no matter how many or how few puffs of air I'm going to put into my syringe, before I record anything from the LabQuest, I need to make sure that the plunger is set at 10 milliliters. That way I know that every single time I get data, it's at the same volume. I can still change number of particles because I can keep putting more air in or taking air out, and I'll show you how I'll do that. But every time I take a measurement, it's got to be at 10 milliliters to make sure volume stays constant. Okay, so how many puffs am I going to do? Well, I'm just going to make this one easy on myself. I'm going to record data at 1 puff, 2, 3, 4, 5, 6, 7, and 8 puffs of air. Real easy, right? Okay, so how do I do that? Well, right now I have the plunger on my syringe pushed all the way in. I think you can see that. So right now there are 0 puffs inside of this syringe. I want to pull back on the plunger until the bottom of the plunger is right at my 1 puff mark. And there it is. Okay, so now I have 1 puff of air, that many particles, in my syringe. And it's only now that I'm going to grab my gas pressure sensor, connect my syringe to the gas pressure sensor. I just screw them together like this. And remember, I can't get the pressure reading until I adjust this the syringe to 10 milliliters. That's why I did not want to cover up the volume markings, because I still need to know where 10 milliliters is. So what I'm going to do, let's go over to the LabQuest screen. I'm going to pull back on the syringe until it reads 10 milliliters. And the trick, as always, is you got to kind of have to hold it there, which I think I'm doing a pretty good job of. And it's right at about 173. We'll call it 173. So let me go back to my data table. At 1 puff, I've got 173 mmHg of pressure. Now, what I need to do, remember, I only had 1 puff in here to begin with, right? I actually need to disconnect my syringe, and I need to refill it now so that it's filled to the 2 puff line. Okay, and I just did that. I filled it up now so it's at the 2 puff mark. Now I can reattach it to my gas pressure sensor. Good. Once again, I have to adjust the plunger so it's at 10 milliliters. I always want to keep that volume the same. So in this case, I need to pull back. And let me go to the LabQuest screen. Whoops, hang on. There we go. Let me pull back on this so that we're at 10 milliliters. And let me hold it there. And we're at right at about 320, we'll call it 326. Okay. Oop, keep accidentally tapping that. So 2 puffs, right at about 326. Okay, I can keep going until I get as many puffs as I need. Let me do one more for you. Let's do a bigger number. Let's do, say, 7. So once again, I need to take off the syringe. I need to fill it up to the 7 puff mark. There it is. Okay, I'm at 7 puffs. Now I can reattach it to my gas pressure sensor. And as it so happens, this time I'm actually going to have to push in on the plunger to get it to the 10 milliliter line. Again, I always want to keep volume the same, so I've got to adjust it however I need to make sure it's at 10 milliliters. So I'm going to push in on the plunger, hold it at 10 milliliters, and this time at right about, we'll call it 1021. Okay. So at 7 puffs, I had 1021 mmHg pressure. All right, thanks to the magic of screencasting, in a second you'll see the entire data table filled in. Okay, as promised, I finished getting the rest of our data points and I filled those in the table. You can see that for yourself. I got the pressure at 3 puffs, 4 puffs, 5 puffs, 6 puffs, and 8 puffs to finish out what we had already collected. And like with the pressure versus volume lab, I thought it might be a good idea just to quickly make a graph of this data just to see if there is any kind of relationship going on. Again, we're going to have you make your own graph and do some more with this data, but I went ahead and I plotted a real quick graph. I'd like to show you that for gas pressure versus number of particles, and I think you'd have to agree there seems to be a very strong relationship here. As the number of particles increases from 1 puff up to 8 puffs, there is a definite increase in the pressure going from less than 200 millimeters mercury up to more than 1100 mmHg. So once again, we seem to have a very clear relationship going on here, and I think I would like to take note of that. So I'm just going to write down here at the bottom that as the number of particles of a gas increases, its pressure also increases. Again, though, we have to add in that caution, right? That this is a true relationship when we keep temperature and volume constant, when we keep those the same. As long as we keep temperature and volume the same, then yes, as number of particles increases, pressure of the gas also increases. All right, I'll see you next time. Bye.